Okay, problem number 9. We have to graph the cotangent function here. We want to start off by finding out the period. And the period for the original graph of cotangent is equal to pi. So we start off by taking pi and dividing it by the value that's right in front of that theta there. So our new period here is pi over 4. I can tell this one's going to work out pretty nicely because I see that my graphing window is going to be from negative pi over 4 to positive pi over 4. So we find key points each time we go 1/4 of pi over 4, and so that means we're looking at pi over 16. Let's go ahead and set up our axis system. Alright, this one's really easy here because I know negative pi over 4 is here, positive pi over 4 is here, and 1/4 of pi over 4 is pi over 16, and pi over 16 plus pi over 16 is a 2 pi over 16, and then 2 pi over 16, 3 pi over 16, and then 4 pi over 16. So we have the negative values on the left here, and looks like because we have an amplitude of 3 here, I'm going to want to go up to at least 3 and down to 3. Alright, so let's start plugging in some points and see what happens. I'm going to start by plugging in 0. If I plug in 0, we have 3 times the cotangent of 4 times theta. So 4 times 0, that gives us 0. What is the cotangent of 0? Might help us to have the unit circle. Okay, so cotangent of 0. Remember, cotangent's definition is x over y. And at 0, we have a 1 over 0, which is going to give us an asymptote. So at 0, we're going to have an asymptote. The start and the end of a period are the same, so we're going to have an asymptote right there as well. Let's plug in pi over 16, see what happens. If I plug in pi over 16, I have 4 times pi over 16, 4 times pi over 16. And that's going to take me to 3 times the cotangent of pi over 4. What the heck is pi over 4? Cotangent of pi over 4. Well, that takes me to this position on the unit circle. And at that spot, I have root 2 over 2 divided by root 2 over 2. And x over y, that's going to give me a 1 times 3, which is 3. So we're going to go to 3 at pi over 6. Alright, so what happens when we plug in pi over 8? Plugging in pi over 8. If we plug in pi over 8, we have 4 times pi over 8, and that gives us a pi over 2. What is the cotangent of pi over 2? Cotangent of pi over 2, we have a 0, 1, and that's going to give us a 0. X 0 over y is equal to a 0, so that's going to give us a 0 here. Well, I know right away that if I were to plug in 3 pi over 16, I would end up with a negative 3 here. And so I'm going to come from my asymptote and approach my other asymptote, going through these points here. And remember, because we have one stamp, we have one cycle of our graph, we can create another cycle over here. So this is our wonderful looking graph. All right, and let's move on to the next problem here. We're going to look at a tangent problem. We have to graph from negative 2 pi to positive 2 pi, and let's go ahead and first figure out what our period is. Our period is equal to pi, the original period of tangent, divided by the value that's affecting that theta there. So that's a 1/4. So we divide by 1/4. And that's going to give us 4 pi. 4 pi. Okay? So I can see here that my period is 4 pi, and the distance from negative 2 pi to positive 2 pi is 4 pi. So I'm going to see just one cycle of my graph from negative 2 pi to positive 2 pi. Let's go ahead and set up the axis system. Okay, so I have the start here, and the distance from negative 2 pi to positive 2 pi is 4 pi. 1/4 is pi, so this is going to give us a decent looking graph here. Let's start just by plugging in these values here and see what we get. All right, we're going to plug in. Excuse me. We'll plug in, starting off with 2 pi. Let's see what happens with 2 pi. If I plug in 2 pi, I have the tangent of, negative tangent actually, negative times the tangent of 2 pi over 4. And this is going to give me, we have negative times the tangent of pi over 2 then. And what is the tangent of pi over 2? It might help you to think about the unit circle here. Pi over 2 is at 90 degrees on the unit circle. And so at that position here, we have x is 0, y is 1. And remember that tangent's definition is y over x. And so we can see here that we'll have something that's undefined. So we're going to have an asymptote at this position. So let's see here. If I was to plug in negative pi over 2 to start, how would that change things? I'd be looking at the tangent of negative pi over 2, which is down here. And down here, I would still have division by 0. And so that gives me an asymptote on this side. All right, so from here, I just have to fill in what's on the inside of my two asymptotes. All right, so let's plug in pi and see what happens. Let's plug in pi. So if I plug in pi, I have the tangent of 4, negative times the tangent of pi over 4. All right, well, what is the tangent of pi over 4? What's the tangent of pi over 4? That pi over 4 takes us here, and that gives us root 2 over 2 divided by root 2 over 2. And that gives us a 1. So we have a negative times 1, which is a negative 1. So we're going to have, at pi, we're going to have a negative 1 right here. And what happens at 0? Let's plug in 0. We plug in 0. 0 divided by 4. And at 0, we're at this position here. X is 1, y is 0. And what is the definition there for tangent? Y over x. So that gives us a 0, which is going to be right here. So I see my last point's going to go there. And so we're going to go through these points and approach our asymptotes. Okay, let's move on to our last problem here. This one was the extra credit one, the doozy. So what we want to do here is to graph and show two periods. What I want to do to start is, okay, so we're going to move on to the next question here. Let's move on to this question. And so we're going to first start off by let's figure out what our period is. Okay, our period is found by the value that's affecting the x here. Now this is x minus 3 divided by 4 is like saying x over 4 minus 3 over 4. So I see the x is being affected by 1/4 there. And so my period is going to be 2 pi divided by 1/4 which gives me an 8 pi. And I have key points that occur at 1/4 of 8 pi, which is equal to 2 pi. Alright, so what I want to do right now is I want to figure out an x value that will give me 0. What x value is going to give me 0, and what x value is going to give me 2 pi. So I'm going to set x minus 3 over 4 equal to 0 and solve for x. I'm going to set x minus 3 over 4 equal to 2 pi and solve for x. So if I multiply both sides by 4, I have x minus 3 is equal to 0, and then x is equal to 3. So that tells me if I plug in 3, I'm going to be taking the cosine of 0. All right, let's go ahead and solve this one here. We have multiply both sides by 4, and we end up with x minus 3 equals 8 pi. And then add 3 to both sides. That gives us 8 pi plus 3. So at this point here, we see that we have a good start and end point for a period. We know that when we plug in 3, we get 0. When we plug in 8 pi plus 3, we end up with 2 pi. So let's go ahead and set up our axis system. All right, we have at the front here, we're going to have a 3, and then let's go ahead all the way to shorten that up a little bit. Let's go to 8 pi plus 3, and we're going to go 1/4. And so let's see here. If I go 3 plus 2 pi, I have a 3 plus 2 pi, and 3 plus 2 pi plus 2 pi is going to give us a 3 plus 4 pi. And then we go 3 plus 6 pi, and then 8 pi plus 3. Alright, so I'm going to go ahead and erase a few things. Okay guys, I got some different things going on here. I added on to the axis going to the left, and here I've shown you that I basically went from 3 and I subtracted 2 pi going in the opposite direction. And I'm showing you the length of each interval is 2 pi. And that's equal to approximately 6.23. Okay, that length is approximately 6.23. And this value here is approximately negative 3.28. And since this value is a positive 3, I know that my y-axis will have to be right down the middle there. Okay, so let's go ahead and start plugging in some values here. Okay, I'm going to start off with plugging in the 3. Okay, so when I plug in 3, I end up with a 0. And so the cosine of 0 is equal to 1. 2/3 times 1 plus 1 is going to give us 1 2/3. So I'm going to go 1 2/3, about right there. Okay, I know the start and the end of a period are the same thing. So I'm going to go all the way to the end here and put a point right at 1 2/3. Let's go ahead and plug in some other values. Okay, starting with 3 plus. Okay, so plugging in the next one, we have that takes us to the cosine of pi over 2, and the cosine of pi over 2 is equal to 0 times 2/3 is 0 plus 1. That gives us a plus 1. So I'm going to put a plus 1 right there. Let's plug in the next value, see what we get. Okay, so when we plug in the next value, here we end up with the cosine of pi. And the cosine of pi is equal to -1. So we have 2/3 times -1. 2/3 times -1 is equal to -2/3. -2/3 plus 1 is equal to 1/3. So we're going to put that point right there. And so I see that I'm going to complete a cycle by putting a point there. And let me go ahead and plot the other points. And voila, we have our other graph that has been vertically shifted up 1, and we have an amplitude of 2/3. I'm running out